Alright, let's see. So for this problem, it is all about trying to use an existing class. So you want to make sure that you kind of just follow through, take a note at the name of the class that you're using, take a look at the instance variables. This should be pretty easy because we only have two instance variables that we have to worry about. There's a goal distance right here. So essentially what you're going to be doing is you are simulating a hopping for a frog, and so that frog has a goal distance it has to hop to, and then it also has a limited number of hops. So with given the limited number of hops, can it make it to that goal distance in time? And here is our constructor. We know that it takes in the goal distance and then the number of hops for this. And then finally, hop distance. This is going to be determining every single time the frog hops, it's going to be returning a number for us. So we are not personally generating any numbers. They took care of that for us, which again, oftentimes when you're doing these problems, there's usually a method that you can utilize, and you may lose points if you're sitting there and writing something up that's already there. So for part A, we're gonna simulate the hopping of a frog. We're gonna return true. So given the max hops number, we're gonna return true if we make it to the goal distance. And the idea of making it there is if we make it there at exactly that distance or we pass it. Um, in all other cases, we're gonna return false, including if we get a negative number, for example. Alright, so let's go ahead and continue. Again, the idea is you probably should have already read through the problem statement, so you have some idea about how or what is going on within the context of the problem. So we're looking at it. We know we are writing simulate. Let's just put that up there. Boolean. Sorry, forgot to write down my string there. Alright, so we know we have some max number of hops somewhere. Let's see what else we know. So we're gonna try to use up as many hops as we can, I guess. And then we're gonna go from there. So we should have a loop that says I'm gonna keep hopping until I cannot hop any longer. Okay, and then we know that we're gonna be keeping track of our total distance. So we're gonna have some sort of distance or position, int position is equal to 0. That's where we start, and then we'll just have a for loop, int counter is equal to 0, and then counter, we know that we're going to continue repeating until we exhaust our number of hops. So while counter is less than max hops, and then counter plus plus. Okay, so for each iteration, we're going to try to see how much we hop. And so we should probably increment position plus equals. We're going to use the method hop distance. Hop distance. That's a capital D there. Alright, so we just made the frog try to hop. And so now we should check. Are we there? Or are we not there? So if at any single point the position is ever greater than or equal to the goal is one of our instance variables called goal distance. if this is true, we're just gonna return true. Return true. So we made it, right? So we're keeping track of our position each time. If the position is there, then we're good. If, however, the position is negative, so anytime the position is less than 0, then one of the requirements is to return false right away. Right? So over here, we have to continue trying to hop until any of those are met. Right here, anytime the frog position is ever negative, we have to go ahead and exit out. There we go. And then finally, we let this continue. And if we don't make it, anything, well, let's go ahead and remove that because I didn't include them in the first one. If we ever make it out of the loop, we know that we haven't made it. We exhausted our number of hops and we did not make it. So we are going to return false. Turn false. Again, each time, remember, we're trying to check to see if we've made it. So we're like, okay, here's another iteration. Have we made it? Have we made it? Have we made it? If not, then we also didn't get into the negatives. But either way, we didn't make it to the goal, so we had to return false. Okay, so now let's do the second one. Part B. Sketch. Okay, let's take a look at part B. So now, hopefully, you've read through part B. So this time around, we are going to run a simulation and figure out the number of times we actually make or reach the goal for this frog. This simulation is going to run n number of times. That n is equal to num. So that is right here. So we're going to run num number of simulations. Okay, so that's, again, pretty good, pretty simple. And then our return is going to be how many times, or it's going to be related to how many times we met the goal versus not. And they tell you the example calculations right here. It's not, they don't want any percentage or anything like that. So we'll just go ahead and return based on this right here. We know it's the number of successes over the number of times we simulated. So let's see, some public double run I'll skip that. Alright, so we know we need a counter. We need to count the number of times we make it. So int total successes is equal to 0. And then now let's just go ahead and run the simulation. Run simulation. For int I is equal to 0, I is less than num I plus plus. So at this point we're running the simulations. Literally all we're doing is we're gonna say simulate each time, and then if we return true, we're gonna increment our successes here. So we're gonna go if we run the simulate method, and it returns true. Of course, this right here is pretty verbose, right? So we can just write if simulate, because we know that that is a Boolean result. If simulate, we're going to add 1 to our total. Total S plus plus. So this loop, again, all it's doing is saying run the number of simulations given by num, and then we are going to return the result, the number of total number of times that we make it versus the number of times we ran the simulation. So return the decimal value, so we're gonna make sure we're casting, and then total divided by num, and that's it. That should be all we needed. Again, we implemented 2 methods for this class. We needed to make sure that we could understand the problem statement by going through their examples. That's some ways that we can kind of figure out how this method works. Probably similar to, coding back problems when they give sample outputs, inputs, etc. This is a class, pretty standard class here. Our instance variables appear, constructors, and then methods implemented by them versus method we had to implement. And then typically, whenever we have two-parter questions dealing with methods, you usually want to use whatever you would have implemented. Of course, whenever you're using a part that you were supposed to implement, when you're using it for another part of the problem, such as in B, you can assume it works.